Let us study some important terms. The adiabatic process. The system which do not allow exchange of heat between the system and surroundings through its boundary is adiabatic system. Adiabatic process is a process in which there is no transfer of heat between the system and surroundings. The wall separating the system and the surroundings is called the adiabatic wall. In the figure is shown an adiabatic system which does not permit the transfer of heat through its boundary. Let us see reversible and irreversible process. A process or change is said to be reversible if a change is brought out in such a way that the process could at any moment be reversed by an infinitesimal change. A reversible process proceeds infinitely slowly by a series of equilibrium states such that system and the surroundings are always in near equilibrium with each other. Processes other than reversible processes are known as irreversible process. The internal energy as a state function. The internal energy represents the total energy of the system. It may be chemical, electrical, mechanical, or any other type of energy. The sum of all these is the energy of the system. The internal energy, U of the system, may change when heat passes into or out of the system, work is done or by the system, matter enters or leaves the system. Free expansion. Expansion of a gas in vacuum, that is when external pressure equals to 0, is called free expansion. No work is done during free expansion of an ideal gas, whether the process is reversible or irreversible. Isothermal and free expansion of an ideal gas. For isothermal, that is when T equals to constant expansion of an ideal gas into vacuum, W equals to 0, since external pressure equals to 0. Also, Q equals to 0. Therefore, delta U equals to 0. Let us study the first law of thermodynamics. The equation delta U equals to Q plus W is mathematical statement of the first law of thermodynamics, which states that the energy of an isolated system is constant. It is commonly stated as the law of conservation of energy, that is, energy can neither be created nor be destroyed. Let us see what are extensive and intensive properties. Extensive property. An extensive property is a property whose value depends on the quantity or size of matter present in the system. For example, mass, volume, internal energy, enthalpy, heat capacity, etc. are extensive properties. Intensive properties. Those properties which do not depend on the quantity or size of matter present are known as intensive properties. For example, temperature, density, pressure, etc. are intensive properties.